It's the only one without time in it. So we're going to choose our fourth equation. We'll plug in and solve. Vf is 0. Vi 2. Negative 9.8. Do not forget the negative. Alright, and your distance is a positive because it's covered upwards. Alright, so let's solve for his initial velocity. We could multiply 2 times negative 9.8 times 6.14. Do that on your calculator while I do it right here. Negative 120.344. Good. I'm going to add that to both sides. And then I have 120.344 equals Vi squared. You can square root each side as your last step to get his initial velocity. So do that on your calculator times 120.344 square root. Get about 10.97 meters per second. He leaves the ground with that velocity, right? Remember, always use way up all your variables. So, lastly, we are going to, I'll just put this right here. We're going to solve for his hang time. That's letter B. What is his hang time? So you have the same givens, all right, except look at your list of givens. Hang time is not in there. We're only using the way up again. So we could solve for T up, will be our strategy. Put a question mark next to T up. And we know his initial velocity. We just solved for that, 10.97 meters per second. Get rid of the question mark. And our strategy is solve for T up, and then double T up, and you have your hang time. So we could really use any equation at that point. The simplest one to me always is the second equation. Vf equals Vi plus At is our second equation. So we could say 0 equals 10.97. Oh, is 10.97 a positive or negative? Well, our initial velocity is covered upwards when it's a tossed up problem. So that is a positive. All right, always ask that question. Is it a positive or is it a negative when I'm plugging something in? If it's up, it's positive. If it's down, it's negative. Acceleration is negative 9.8. All right, and you're solving for T up in that equation. Right? Always using the way up. Now, you can solve for T up. You could make it, move the 9.8 to the right side. It becomes a positive. You could divide then both sides by 9.8. And you've got T up. 10.97 divided by 9.8 is 1.12 seconds. So your hang time is twice that. 2.24 seconds. That's the hang time. So when we're looking for hang time, never just solve for T, because we're always going to use the way up, so it's going to be T up when you solve for it. And even if you're plugging in a time, you have to plug in T up. But you can't just plug in a hang time into those equations, because we're always using the way up to calculate. Hang time you'll have to find with an extra step always after you use the kinematic equations. All right, thanks guys.